All right, so hello everybody. So there's an animation in your book, right? So there's a bond's price versus its yield to maturity, and you can see as the price goes down, the yield to maturity goes up. Is that clear to everybody? And I think there's a slider here that see that? I don't know if there's a number it's telling you, but you can clearly see as the price goes up, the interest rate goes down. Oh, so here, there's a number down here. Let's see. So if I move that, you see the current yield to maturity moving? I don't know what this does. Oh, all right, it moves it in steps. All right, so I just wanted, it's in your book. I wanted you to see that. All righty, so that's right here. All right, so a coupon bond is not a zero coupon bond. In this case, it's like there's a corporate bond or a zero coupon bond. Corporate bonds pay coupons. All right, now treasuries have treasury notes and treasury bonds. Treasury notes are usually between, I don't know, between maybe 2 years and 10 years, and treasury bonds normally are more than 10 years. All right, so there's different terminology, and you could read up on these, right? All right, so treasury securities. Then of course I said there's coupon bonds, corporate coupon bonds. Okay, so here's the cash flow of a coupon bond. So $1,000, 5% coupon, semi-annual. That means $50 a year divided by 2 is going to be $25. Everyone see that right here? So here's the timeline. And then you get your money back at the end of the year, at the end of 10th year, okay? They should show what you paid here. I don't know why they didn't show the original price you paid. I guess they're just showing you the coupons, all right? And your final payment. So So even though it's a treasury bond, basically they're just showing you. Okay, they're just showing you what cash flows. They didn't show you what you're paying for it. But oh, here it is right here. So here you are paying for it up front. You know that's negative. You notice that, right? And here's the coupons, and then there's the last coupon, and you get your money back. All right. So here's the yield to maturity of a coupon bond, a regular coupon bond, right? This is what yield you're going to get, like a corporate bond. All right. So there's no simple formula to solve for the yield to maturity directly. Instead, we need to use trial and error, or absolutely, you know what we're going to say. I'm going to say we use Microsoft Excel. In fact, here it is. You can use Excel's internal rate of return function, right? Or the rate function. So there's a couple ways to get that, and we'll see if there's examples in here. So when we calculate a bond's yield to maturity, the yield we compute will be a rate per coupon interval. Okay, so that would be like every 6 months, right? Per coupon interval. Okay. The yield is typically stated as an annual rate by multiplying it by the number of coupons per year, thereby converting it to an APR with the same compounding interval as the coupon rate. All right, so here we are in Microsoft Excel computing the yield to maturity of a coupon bond. So you can see they take, here it is a face value. You see they put $1,000 when it matures with a 5% coupon rate. So 5% coupon rate every 6 months here means you're going to get $25 every 6 months, right? $25 every 6 months. There it is. And it's 5 years, but it's 10 6-month periods, right? So that's why this is a 10, okay? So and then it says you currently paid this much for the bond, right? You currently paid this much for the bond. So listen carefully now. Because you paid less than the face value, the prices has gone down here, which means the yield to maturity has to be more than 5%, right? The price went down, is low. So right? So you basically paid this much. Okay, you paid this much today, and it goes up in price. So it went from a low price to a high price. So actually, it's gone up in value. Excuse me, it's gone up in value. Okay, so it's gone up here, but you got to remember, like this is the current price you paid. Now, typically, this bond would have been at par for 1,000, but this is the current price. So the current price has gone down. It will go back up to 1,000 when it matures, but it's gone down currently. You paid less than the par. So if it's gone down, the interest rate has to go up. So it's going to be higher than 5%. So you can see it's 3%, but that's every 6 months, right? Okay, this is you see what it says? This yield is for a 6 month period, and basically, thus the bond would has a yield to maturity equal to 6% APR with semi-annual compounding. Okay, with semi-annual compounding. All right, so let's go through this little nice example here.
Computing the yield to maturity of a coupon bond. So we're going back to the bond we considered in example 6.3, which was the 5-year $1,000 bond with 2.2% coupons and paid semi-annually. So we have the cash flows repeated up here. It's May 2013. First coupon of $11 is paid in 6 months in November 2013, and so on until May 2018 when you get your last coupon and you get the face value, the par amount, paid as well. So equation 6.3 tells us that the price of the bond is just the present value of the cash flows coming to you from the bond. So the first part here is just the annuity of coupon payments. You get a coupon payment every 6 months for 5 years, and that's just an annuity, and so we solve it with the annuity formula. And then you have this one extra cash flow at the end, the $1,000 face value, the par value, and that's handled by just adding on this one extra cash flow at the end and discounting it back to the beginning. The important part here is that since our cash flows are paid every 6 months, we're going to be computing a yield to maturity that is expressed as a 6-month rate, and we'll have to double it to convert it to an APR. So let's look at what we know. The price is $963.11. The coupons are $11. We don't know the yield to maturity, so that part, the Y, is what we're solving for. We know that the total number of 6-month periods is 10. It's 5 years, but the cash flows are paid in 6-month intervals, so everything has to be done in terms of 6-month periods. So N is 10 here, 10 6-month periods over the 5-year life of the bond. And finally, the face value of $1,000 is paid here at the end. Again, we don't yet know what Y is. We're solving for that, and that's paid in 5 years or 10 6-month periods. Now, it turns out that we can't algebraically isolate Y and just solve out for Y here. So what we'd have to do is we'd have to do trial and error. We try a guess for Y and see what happens, and then try another guess, and eventually try to narrow in on the guess that makes this set of cash flows have a present value of $963.11. Or we could just have a computer or financial calculator make guesses for us really, really fast. And that's exactly what they do. If we actually went through and used Excel or used a financial calculator, we'd find that Y turns out to be 0.015 or 1.5%. Now that's 1.5% per 6-month period, because everything in the formula here is done in terms of 6-month periods. The rate that's going to come out is also a 6-month rate. So to express it the way rates are expressed in the bond market as APRs, we just have to double that. So that implies an APR of 3% semi-annually compounded.
Okay, so there's another one here, and they use the financial calculator. Let's watch this.
Computing the yield to maturity of a coupon bond. In this example, we return to the bond we considered in example 6.3, which was technically a treasury note because its original maturity is only 5 years. It's a 5-year, $1,000 bond with a 2.2% coupon rate and semi-annual coupons. As we worked out in example 6.3, the cash flows to this bond are $11 every 6 months. So that's the coupon rate of 2.2% times $1,000 is $22. That's for a whole year, but the coupons are paid semi-annually at $11 every 6 months. That'll happen every 6 months for 5 years for a total of 10 payments. And then at the end of 5 years, you get the face value, the par amount of $1,000 as well. So now to solve for the yield to maturity with a financial calculator, we have to enter in some information. So the number of periods is going to be 10 because since the cash flows come at 6-month intervals, we have to do 6-month periods. So 5 years is 10 6-month intervals. So we hit 10 and then N. And it starts our cash flow timeline up here. Now the payment is the $11 that you get every 6 months. So that's our payment. And then the future value is that par amount you get at the end of 5 years, the 10th 6-month period of $1,000. So we get 1,000 future value. The present value is the price. Remember, the price of a bond is just the present value of the cash flows you get from buying the bond. So the price is $963.11. $963.11. In order for the way the calculator works to actually give you an answer, the present value has to be the opposite sign of the cash flows. So we take that 963.11 and we make it a negative, and then we enter it as the present value. Okay, so now we have all the information that we have, and we're solving for the interest per period. It says interest per year here on the financial calculator, but that's just because its standard is a year. We're doing periods of 6-month intervals. So we're going to hit compute interest per year, and it comes out as 1.5. Now remember, we started this as 6-month intervals, so 1.5% is 1.5% every 6 months. So to state this as an APR, the way bond rates are quoted in the market, you'd have to double it because there's 2 6-month periods in a year, and it would be quoted as a 3% APR semi-annually compounded. That would be the way the yield to maturity of this bond is quoted.
All right, so I'll stop there. I'm not running out of time, and I will pick it up here on this other video for part 3.